we now learn the quotient rule. Remember before we learned the product rule to handle derivatives of products, which we couldn't just take before. Turns out the derivative of the product is not just the product of the derivatives, it's something a little more complicated. Well, the same is true for the quotient rule. Turns out the derivative of a quotient is not just the quotient of the derivatives. You can't just do the derivative of the top divided by the derivative of the bottom. So you can pause the video and take a look at problem 4. And we are going to use the quotient rule to solve it. But in order to do that, we first have to state and prove the quotient rule. And like the product rule, it's a little messy. The derivation is going to take a little bit, but and it's not something you'd ever be tested on, but it's still something you should see. So it turns out the derivative of f of x over g of x, or another way to write this is d of dx over d over dx of f of x over g of x equals, and it's going to be g of x f prime of x minus f of x g prime of x all over g of x quantity squared. Now, how are we going to derive this? It'll be somewhat similar to the product rule. We're going to use a limit definition, because that's really all we've got. And we're just going to do a bit of common denominator stuff. We are going to do the whole adding 0 trick one more time. So we're just going to see we've got this. Right, this is our limit definition of the derivative. Lovely, right? So what we're going to do is, we're going to do the thing where, we put the 1 over h on the outside, right? So we don't have to deal with the repeated fraction. And then we're going to make a common denominator. And when you do that out, it winds up being this. Oh, try a little bit better. Here's our common denominator. There we go. All right. So we've got this fraction here. All right, and we somehow have to write it in terms of functions and derivatives and all sorts of stuff. But maybe just to point out, we might start to see where our g of x squared is going to be coming from. Okay, just something to keep in mind. All right, now continue writing our limit as h approaches 0 of 1 over h times this big thing right over here. Once again, we are going to add 1. So it's going to be f of x plus h g of x. And then we're going to subtract f of x g of x. And then add f of x g of x. You see that? You see how we subtracted something and added it right back? So actually, sorry, I said we were adding 1. We're adding 0. We added 0, right? This whole thing, this whole thing right here is 0. Okay? And then we're going to subtract f of x, g of x plus h. Whoop, that's an h. And then this is all divided by, of course, g of x plus h, g of x. All right. So anyway, let's keep it going. Limit as h approaches 0. And we might have to start to separate some things right here. So let's see what we're going to get. We're going to get, well, notice that we're going to sort of split it, the fraction right here, and we can factor out a g of x. So we're going to get f of x plus h minus f of x. And then this will all be over g of x plus h. Actually, you know what? Actually not gonna put that over here. What I'm gonna do is I'm actually gonna tighten this up a little bit, put this over here, and this is actually gonna be times g of x. I'll do the whole numerator first, and then I'll do the denominator afterwards. Okay, and then this is going to break. You see how I just want to show you how I factored out this g of x right over here. Okay. And then this is going to be plus 1 over h, or sorry, I should say rather, yeah, I'm going to split up the 1 over h as well, right? So we're going to be 1 over h times f of x times the fraction, oh, actually, I guess we have g of x minus g of x plus h. Why don't we do this minus, and now it's g of x plus h minus g of x. And there we go. And now maybe we can divide this entire thing by g of x plus h times g of x. Okay, and maybe using a couple of limit laws, what we can do, and maybe just writing things a little bit differently, we can rewrite this as the limit as h approaches 0 of f of x plus h minus f of x all over h times g of x minus the limit as h approaches, actually I really should, I'll put the f of x out here first. Limit as h approaches 0 of g of x plus h minus g of x all over h. And then all of this is over the limit as h approaches 0 of g of x plus h times g of x. And this winds up being, sure enough, well, I guess I'll write the f prime first. F prime of x, g of x, minus f of x, g prime of x, all over g of x, quantity squared. All right, that's what we have. So just want to point out one thing. You could write the quotient rule this way. And this is just a mnemonic. Feel free to ignore this if you're good at memorizing this. This is the same as, I guess I'll write it like this. G of x, instead of writing f prime of x, I'll write it as d over dx of f of x minus f of x times d over dx g of x all over g of x squared. And the reason is you could read this as low d high minus high d low all over low squared. So it's a good mnemonic. A lot of people use it. You don't have to. Okay. So anyway, let's go back to this problem. We need to find the rate of change of r, right? We need to find s of x, right? So s of x equals r prime of x, which equals low d high, 96x cubed, minus high, ooh, you know what? I don't think I'm going to have the room here. I'm going to have to move this over here. Minus high d low all over low squared. Okay? So that's what we get. And of course, you could simplify this if you like. I will not do that in this case. Okay? So let's do a couple of examples here, right? Here we have, for one, dy over dx equals low d high minus high d low, because e to the x is its own derivative, all over low squared. And if you wanted to simplify this, you could e to the x times 1 minus x all over e to the 2x. And we can actually simplify this a little bit more and just have 1 minus 2x over e to the x. For number 2, dy over dx equals, and again, I have no plans to simplify this guy. It says simplify when possible, but this is a little much. Low D high minus high D low all over low squared. Okay. Quotient rule. All right, let's take a look at this guy. Well, you could do the quotient rule if you wanted. I personally think you should rewrite this as f of x equals 3x plus 2 over root x. Right? See how that's a little bit better? 3x plus 2x to the negative 1/2. And so f prime of x, just to be clear, that's f prime of x equals 3 minus x to the negative 3/2, or 3 minus 1 over square root of x cubed. There we go. And then number 4, I don't think we're getting out of using the quotient rule for number 4. So we're just going to have low D high. Oops, I guess we should write g prime of x equals low D high minus high D low, and that's going to be 1 over 2 root x, all over low squared. We could simplify this a little bit, right? Looks like we're going to have a factor of 2 here. It's going to be 2 times 2 plus root x minus, and then we factored out the 2, and we're getting just root x. Well, that works out pretty nicely. Yeah, so I think actually these will cancel. I think I'm doing that correctly. And we just divide by 2 plus, no, 2 plus root x squared. And that's what we get. So I think it winds up being 4 over 2 plus root x squared. All right, one more example. Find the equation of the tangent line to this curve, right? Or this curve at that point, right? So we have dy over dx equals, what is this going to be? Low d high minus high d low all over low squared. And we could simplify this a little bit. This is going to be 2x plus 2 minus 2x all over x plus 1 squared. And that really equals 2 over x plus 1 squared. Now here's a nice little bit of notation. You can then, let me actually bring this down here, just for space purposes. You can then say, okay, evaluated at x equals 1 to get 2 over 1 plus 1 squared. That's sort of a way of plugging an x value into the derivative, which winds up being 2 over 4, which is 1/2. Okay? So we wind up having, so y equals 2x over x plus 1 has tangent line. What would it be? Y minus y1 equals the slope, right, which we found right here, times x minus x1 at the point 1, 1. There you go.